The site is an Air Force asset composed of 3 antennas with 4 radars on them that execute tasking for the DoD under an Air Force contract and do space surveillance on their behalf. So we call the site loosely, we call it Millstone. So if you take the site as a whole, we're doing space surveillance in all the orbital regimes near the Earth, from low Earth orbit to medium Earth orbit, where GPS satellites live, to geostationary orbit, where communication satellites live. Millstone Radar's mission or capability is to perform what we call metric tracking. So Millstone Radar can look at a satellite, measure a portion of its orbit, and then we use that, and that's very, very precise data. We use that precise data to compute the orbit and define it mathematically. And then we can use that orbit in the future to figure out where to go find that same satellite again. The other radars are designed to learn more about the targets that we're looking at. So they're imaging radars. That's HAX and the Husar X-band radar and the Husar W-band radar. Husar, by the way, stands for Haystack Ultrawideband Satellite Imaging Radar. HAX is the Haystack Auxiliary. It's a different antenna and a different radar. But combined, those 3 radars are all imaging radars. The radars produce products with varying resolution, varying clarity. Husar W-band radar is the most capable that we have, and it produces clarity, image resolution down to about 2 centimeters. That's basically the site's mission in a nutshell, is to measure satellites' orbit, get images of a satellite, determine their health, their status, in some cases determine their mission, and report that data back to the Air Force. So the Air Force has a whole arsenal of radars at their disposal that are called dedicated sensors. They're on the air 24 hours a day, 7 days a week. They're generally staffed by active duty Air Force people. Our radars are not like that. Our radars are called contributing sensors. We're on the air part-time, generally about 70 to 80 hours per week per radar on varying schedules, but none of them are 24/7. In the time that we're not on the air, we do a lot of research and development, constantly trying to make the radars better and push the edge of the envelope on the capability of our systems and come up with a better way and a more capable sensor. We push that out to the Air Force. In addition to the mission that we do for Space Command, we also support NASA. We do debris data collection for NASA using the Husar X-band radar. NASA is primarily interested in orbital debris population in the near-Earth orbital regime, where we have manned space flight in the form of the International Space Station. We use Husar X-band radar about 500 hours a year to collect statistical data on the debris population. And that data goes to NASA. NASA creates something called the orbital debris model. That's used internationally in the interest of safe space flight for manned and unmanned missions.